Alright, just wanted to make a video going through the warm-up for those who missed class or haven't or struggling with the warm-up, just to make sure we're good to go on this stuff. So it says list the possible rational zeros, then write the function in factored form and find the zeros. Finally, sketch the graph of the function containing all zeros, intercepts, and the end behavior. So listing all possible rational zeros, that's asking us for p's over q's. Specifically, the p's come from the constant term, so we have 1 and 21, 3 and 7. The q's come from the constant term on the first, the largest variable, highest power I should say, the variable with the highest power, and that would just be 1 and 2. So if we're listing all the possible rational zeros, we start with plus or minus. We always start with plus or minus. And then we go parentheses, and then it's always p's over q's. So we're going to take 1, 3, 7, and 21, and we're going to divide them each by 1. So that would just make 1, 3, 7, and 21. And then we're going to take all of those terms again, but now we're going to divide them by 2. So that would give us 1 half, 3 halves, 7 halves, and 21 halves. Those are all of the possible rational zeros for this function. Y-intercept, we just need to plug in 0. So you plug 0 here, that would go away. You plug 0 here, that would go away. 0 in for that. 0 here, and that would go away. So then the last thing we have is just negative 21. So the y-intercept would be 0, negative 21. And then it says solve for the zeros. The hint is, if it were me, I'd try using a 3 first. So we're going to start with 3, and then let's do synthetic division. So we have 2, negative 5, 11, negative 35, negative 21. So that's 2, 6, 6 and negative 5 makes 1, 3 times 1 is 3, 11 and 3 is 14, 3 times 14 is 42, negative 35 and 42 would make positive 7, which makes 21, which makes 0. So that's 2x cubed plus x squared plus 14x plus 7. Remember, it's constant remainder, x squared, x cubed. So I don't give you a second one to try out. So that means this must factor by grouping. So let's check it out. If we pulled out an x cubed out of the first two terms, that would leave us with 2x plus 1. Or sorry, if we pulled an x squared out of the first two terms, that would leave us with 2x plus 1. If you pull 7 out of the next two terms, so positive 7 gets pulled out, again you would be left with 2x plus 1. So there's our factor by grouping. So this factors into, we pull a 2x plus 1 to the front, and we're just left with x squared plus 7. So, factored form, we would say f of x, or y, is equal to x squared plus 7 times 2x plus 1, and then we can't forget this 3, that factor is x minus 3, because this is the x-intercept. So we always need to just say 3 is equal to x, you subtract the x from both sides to get that factor, x minus 3. So what are the x-intercepts here? Well, we have 3 for sure, 2x plus 1, you solve that for x is negative 1 half. We solve x squared plus 7 is equal to 0. You subtract the 7 from both sides to get x squared equals negative 7. And then you would just square root both sides of this and get x equals plus or minus I radical 7. So plus minus I radical 7. And then using all of this information, let's draw a sketch of this function. So we know that zeros are at positive 3, so 1, 2, 3. Negative 1 half, so I'll just go out 3 again. Negative 1 half. It's going to be right here. We know that the y-intercept is negative 21. We'll count by 3, so 3, 6, 9, 12, 15, 18, 21. Would be right there. I'll just label that so we know that we counted by 3. Negative 21. And then let's look at the function. The function is fourth power, which means it's even, and it's positive, so it means it's opening up and up. So then our function should look something like this. And there's a graph of that polynomial function. All right, let's take a look at number 2. Given f of x has leading coefficient of 1 and the following zeros, determine the least degree of the function, write f of x in factored form, and then rewrite it in standard form. So if 3i and negative radical 5 are both zeros, then the other two zeros would be negative 3i and positive radical 5, okay? Imaginary numbers and irrational numbers always come in pairs. So if you have the positive or negative version, you have to have the opposite sign, okay? So the least degree of this function, because there's 4 solutions, means that the least degree is 4. And if we wanted to write this in factored form, sorry, this is negative 3i. If we wanted to write this in factored form, you would just need to solve all of those back for 0. So you could set it x is equal to 3i, and you just subtract the 3i to get it back to 0. So x minus 3i is a factor. And it's just the opposite sign in each of these. So negative radical 5 would be x plus radical 5. Negative 3i would be x plus 3i. And then positive radical 5 would be x minus radical 5. So that would be factored form. If we wanted to write it in standard form, what you have to do is you have to multiply all of these out. You need to be super careful when you're multiplying these things out. You should always multiply the imaginaries with the imaginaries, and then you should always multiply the radicals with the radicals. You don't want to start multiplying 3i by radical 5 because that's going to start to get very confusing very quickly. Okay, so let's do the imaginaries with the imaginaries. X times x would give us x squared. Then we have x times 3i, so that's positive 3i. And then we have negative 3i times x. Oops. This should be 3ix. I apologize, right? Because x times 3i would be 3i times x. Negative 3i times x would be negative 3ix. And then negative 3i times positive 3i. The 3's get multiplied. Negative stays there. So it's 9i squared. Okay? So why is it important to multiply the i's together? Because these middle terms go away. And you're just left with x squared. And then 9i squared, negative 9i squared is negative 9 times negative 1, because I squared is negative 1. So that's plus 9. Awesome. On the other side here, we do x times x, which that gives us x squared. We do x times negative radical 5, which is negative radical 5 times x. We do negative radical 5, or positive radical 5 times x, which is positive radical 5x. And then lastly, we do positive radical 5 times positive radical 5, which gives us negative radical 25. Sorry. Positive radical 5 times negative radical 5. I am misspeaking today. If you look at this, the reason we multiply the radicals together is because the middle terms will cancel again, and then this will simplify down to x squared minus 5. At this point right here, you should be able to see all 4 zeros. Note if you solved this for x, you would get plus or minus 3i. If you solved this for x, you would get plus or minus radical 5. Okay, so we're in a good spot. That means we've multiplied everything together correctly. All right, now we need to go to standard form, so we need to go one more step multiplying. Okay, so we go x squared times x squared, that gives you x to the 4th. 9 times x squared is positive 9x squared. We got negative 5 and x squared, which is negative 5x squared, so that's going to be a positive 4x squared in the middle. And then positive 9 times negative 5, which is negative 45. Okay, so it's all about just making sure that you multiply all of those things together. All right, so that's standard form. We started with the factored form. It's just a lot of multiplying there. Question number 3. So this function is shown below. Use the graph to find all the solutions of the function. How many zeros, real and imaginary, does this function have? It's a 4th power. Okay, the degree tells us the number of solutions, so that means there's 4 solutions. it says find all the zeros. Well, if we just look at the graph, we can actually see 2. There's one right here at -2, and then there's another 0 right here at 1.5 or 3/2 is what I like to write there. So we already know 2 of them. We know -2 and we know 3/2. So how are we going to find the rest of them? Because that's only 2 of the 4. We know that there has to be 4 because of that degree. So then we go here and we say, okay, well, if we do -2 and we divide that original equation by that factor, it should give us a lower degree function for us to work with. Drop the 2, gives us -4. 1 and -4 makes -3. -2 and -3 makes 6. 2 and 6 make 8. -2 and 8 makes -16. -16 and 4 makes -12. -12 and 2 makes +24, which gives us 0. So now we have 2x cubed minus 3x squared plus 8x minus 12. And then, as you can see, we could use 3/2 again to make this even more simple. So we go 3/2. That's going to be 2, -3, +8, -12. So that's 2. 3/2 times 2 would be 3. So -3 and 3 is 0. 0 times 3/2 is 0. So that's 8. 8 times 3/2 is going to be 8 divided by 2 is 4. 4 times 3 is 12, which gives us 0. So then our equation right here is 2x squared plus 8. So that's the equation that we're going to use to find those last 2 zeros. So if we just set this equation equal to 0, subtract the 8 from both sides, you get 2x squared equals -8. Divide by 2, x squared equals -4. Square root both sides to get x equals plus or minus 2i. So the last 2 zeros here, positive -2i. Awesome. Okay, so that is basically all of 4.6 and 4.7. That's every every concept right there. Okay, P's and Q's, graphing. We found this is a huge concept in 4.7, right? That imaginary numbers and irrational numbers come in pairs. And then last but not least, let's look at a multiplicity question. So it says answer the following questions about the function, then sketch its graph. So the degree of this function, whenever you're looking at the degree, you need to see how many x's there are. There's 1 here. There's technically 3 x's here, because that's x cubed, so 3. And then x squared here, so that would be 2. So 1, 2, 3, 4, 5, 6. So 6th degree function. What are the x-intercepts and their multiplicities? To find them, we need to set each factor equal to 0. This -2x, because it's getting multiplied, is a factor. X minus 3 to the third is a factor, and x plus 1 squared is a factor. So you don't need to put the cubed and the squared, but all you need is x minus 3 equals to 0, x plus 1 equals 0, and -2x squared. -2x is equal to 0. So that first one, if we add 3 to both sides, you get x equals 3. The multiplicity comes from the power of that factor. So it's 3, so that means the multiplicity is 3. The next one is x equals -1. That has a factor, or a degree of 2 on it, so that has a multiplicity of 2. And then the -2x, you divide by -2 on both sides, and you get x is equal to 0. The degree on that x is a 1, so this is a multiplicity of 1. All right. If we're talking y-intercept, you just plug 0 into the equation. -2 times 0, 0 minus 3 cubed, 0 plus 1 squared. So that gives us -2 times 0 is 0. 0 minus 3 is -3 cubed. 0 plus 1 is 1 squared. So that's 0 times -3 cubed is -27. 1 squared is just 1. So that's 0 times all of that, so it's just 0. Which that should make sense because we're crossing the x-axis at 0 as well. So we graph all these points. We're at 0, 0. We're at +3. We're at -1. And then we have that y-intercept of 0 already graphed. At this point, it's about the degree of the function and if the leading coefficient is positive or negative. That's going to tell us where the ends of our graph are. Even degree says it's going to open together, 6 degree. Negative says it's going to open down. So we're negative, which means we open down. And together because it's even. So at -1, we have a multiplicity of 2, so we bounce. At +3, we have a multiplicity of 3, so we're going to look like a cubic going through that function. So something like this, because it's going down. So then our graph should come up from the bottom, because it opens down, bouncing off of this, but then we have to go back through 0, and then we're going to look like a cubic going through this part. And then there's our function, okay? Definitely not the most beautiful graph you could ever draw, right? But it gives us a good idea of what this function looks like. So that's the multiplicity question. If you guys have any questions, as always, message me on Canvas. All right, I'd love to answer those questions. But I hope you have a great day studying.